Okay, so we're starting a rational unit. So our rational parent function is 1 over x. So we're going to find our independent variable in the denominator. You're not going to have to graph these just yet, but when we get to graphing these, what we're going to have are two curves. So everything that we've done up until now, linear, quadratic, absolute, square root, we could draw those graphs without ever picking up our pencil. But what I just drew right now, I had to pick up my pencil to move from quadrant 1 to quadrant 3. So we have what's called a discontinuity. Everything else has been continuous. The minute I pick up my pencil, I have a discontinuity. And we're going to see multiple asymptotes. We're going to see a vertical and a horizontal asymptote with rational. That's just where we're headed. That's not what we're worrying about so much today. But I wanted you to see the rational parent function. So when we first start looking at rational parent functions, we compare this idea of inverse variation to direct variation. Direct variation is basically a linear equation that goes through the origin. Okay, direct variation. So it's a linear equation. So back in Algebra 1, it would have looked like y equals mx because the b value would have been 0. So if I take that same equation into Algebra 2, we replace the m in slope with the a parameter change. But it's still slope. A tells us how steep or flat our graph is going to be. It tells us if our graph flips across the x-axis. In this particular unit, we substitute the letter A with a K. Now, I'm not saying K up and down K. K is going to stand for a constant of variation. And I was going to write it with a K, constant, because it's a German word. I'm not going to write it with a K. We're going to write it with a C. So our A value, this case, our K value is our constant of variation, or sometimes we call it our constant of proportionality. Proportionality. And we're going to see this constant in both direct variation and in inverse variation. Our inverse variation is going to be a rational function. All right? We are only going to look at that a parameter change. With inverse variation, we're not going to see the graph shifted left and right. We're not going to see it shifted up and down. So there'll be no horizontal or vertical translations. No slides. Translations. So we're just focused on that A value. So sometimes we use K instead of A, but only with this direct and inverse variation. The rest of the year, K is what's going to shift our graphs up and down. All right, so when if I look at linear equations there, if I look at that y equals k times x, if I wanted to get the k all by itself, what would I have to do to this little equation here to get k by itself? I'd have to divide by x, right? So k is found by taking y and dividing it by x. So if you know one ordered pair, if you know one xy value, you can write your equation if you know you're dealing with direct variation. You only need one ordered pair. Inverse variation is going to follow this format, y equals k over x. If I wanted to get this k by itself, what would I have to do? Multiply both sides by x. Right? Multiply by x, that cancels. So I have x times y. All right, so I'm going to find my k value either dividing y and x or multiplying the x and the y together. All right, so we have some tables below. that we're going to determine if our tables are direct variation or inverse variation. We'll know it's direct variation if your k value is y over x. We'll know it's inverse variation if our k value is x times y. All right, so we've got some examples here we're going to practice with. So what I'll do is I'll take my table and I'll just extend it a little bit. Okay, I'm going to take my table and I'm going to extend it. In one column, I'm going to write y over x. In the other column, I'm going to write x times y. Y over x and x times y. And I'm just going to do enough of this table that I can find which number repeats itself. So if I take 25 and divide it by 2, that's why you guys have calculators, what would I get? 12.5. Good. And if I take 10 and divide it by 2, I get 2. Okay, those numbers aren't the same, so I'm going to move on. So now let's multiply x and y. So 2 times 25 is 50, and 5 times 10 is 50. Okay, so I found my winner because I have a constant x times y. So if we have a constant x times y, what type of variation is this? It's inverse variation. I'm going to just write that down in the bottom here. So this is going to be inverse variation. So we just found our k value. Our k value was 50. Now when you write inverse variation, the k value is in the numerator. So this will be 50 over x. Okay? So finding k for inverse variation, k equals x times y, but the equation of inverse variation is y equals k divided by x. So this is finding k, but ultimately you're going to write your equation as k over x. All right, so I have one thing to do. Guys, please, on the quiz every year, I give you a table with one blank. You have to fill in the blank. All right, so I can use the formula now. I have my formula here, y equals 50 over x. So to find my y value that's missing, I'm going to take 50 and divide that by 12, and what does that give me? What's repeating, the 6 or the 1/6? Okay. So I'm going to put that 4.16 with the repeating bar there. So make sure we go back and fill in the missing slot. I don't need you to fill in the rest of our extension over here. Just fill in the missing box. All right, so let's look at the second table here. I'm going to start by taking y divided by x. So 8.4 divided by 2 is 4.2. And what's 21 divided by 5? Oh, that's 4.2. Okay, so these are all constant. I don't need to go and do the second column because I can't have y over x and x over y be the same thing, so I can stop now. So I have a constant of variation of 4.2. Because my constant of variation was found when I took my y's and I divided it by x, what type of variation is this? This is direct variation. So when you write the equation for direct variation, you are going to just put the k in front of the x. So my equation would be 4.2 times x. If I were trying to solve for k equals y over x. Okay, these are the same equations, they're just manipulated. So what's the last thing I have to do before I can move on? Right, I need to say 4.2 times 12 is how much? 50.4. All right, so we're going to fill that in. All right, so far so good. So I can give you a bunch of tables. Now, if you don't see a common number in the y over x column, and you don't have a common number in the x over y column, then you just say neither. And you don't have to fill anything else in. Okay? If it's neither direct nor inverse variation, you're done. You don't have to find k, you don't have to, there is no k, and you don't have to write an equation. All right, so we have a few word problems here. I want to remind you, like if you look at this corner of my wall, we've talked about y being a function of x. We've talked about y depending on x. So what's also going to hold true in this section is y varies with x. So when I read the situation, I've got a refund on our cans varies directly. So I see this varies directly. That tells me direct variation. Okay, so I'm going to say direct variation. My equation will be y equals k times x. If I get the k by itself to find k, I'm going to take y and divide it by x. So it varies directly. So what's in front of the words vary directly? I've got here the amount of the refund. So this is my y value. Varies directly with the number of cans. Y varies with x. So I've identified my two variables. So now I need one ordered pair. I need one x, y value that goes together. All right. So let's see. So the refund is the y. And I've got a refund of 40 cents. And I've got for 25 cans, cans is an x value, so that's 25. So here's my one ordered pair that I'm able to pull out of this scenario. I'm going to find k. We find k by taking y and dividing it by x. So what is that? What is 40 cents divided by 25? 0.016? Okay. So basically, what this is saying is I'm going to get a little less than 2 cents a can. Okay, so now I'm ready to write my equation. So I might start with saying y equals 0.016 over x, except that wouldn't be following directions, because directions are saying I want to use these specific variables. So I'm going to rewrite this as my refund is equal to 0.01, ooh, hang on, direct variation, I wrote that problem right, didn't I? Oh, this isn't right. Yeah, multiply. Good. 0.016, right, 0.016c. There we go. So here's my final answer. I was writing inverse variation instead of direct variation. There we go. So now we have this equation that we can use to answer the next couple questions. So P equals 0.016c. All right, so if I want to know how much my refund would be, so find P if I turn in 100 cans. Yeah. Now these are word problems, so make sure you have some either kind of units or words in your answers. The last one says if I want to earn $100, can I find C? So what am I going to do here? Right, I'm going to divide by 0.016. So this is just, these are going to be one-step equations. 6,250, and you said can's good. So you are going to need a calculator to help you with some of your homework, but your phone is would be sufficient. It's just helping with multiplying or dividing. Okay? I think we've got one more example. This example is telling us varies inversely. So here I've got a situation where pressure varies inversely with volume. So pressure, this is something you guys are doing in chemistry, varies inversely with volume. Y varies inversely with x. Okay, so if I'm doing inverse variation, right, if I'm doing inverse variation, my final equation is going to look like y equals k divided by x. And how am I going to find that k value? How would I get the k by itself? Multiply x and y together. Okay, so I just need to find an x and a y value. I've got pressure of 46, so that's my y value. And volume is 360. Good. So to find my constant of variation, I'm going to multiply 46 times 360. And there's my K value. Because I'm going to use the variables P and V, P is like my Y value, V is like my X value, so I'm using my inverse variation, and now I have my equation ready to go. And I can use this equation to answer the last two questions. 16,560. Okay, so what's the pressure? So find P to compress the gas to 276 cubic feet. So 16,560 over a volume of 276. And what would that give me? Oh, you guys, what is yours? Maybe I should. Oh, yours is the other way? Okay, let me. Okay, so your question. Okay. Okay, so your problem says if the pressure is 276, 16,560 divided by V. Well, I'm going to do the same thing. Do you guys know how to solve a problem like this? All right, well, what I'd probably do is cross multiply. I'd multiply, so 276 times V equals 16,560, and then divide by 276. All right, so what would my volume be here? What's 16,560 divided by 276? I think it's just 60. Okay. 60, and then volume is in cubic feet. If I would have gotten the same answer here, but I would have put PSI. All right, and then the last question says, can I compress the gas to have a volume of 0? Can I get a 0 here? No? I can't have a 0 in the denominator, right? Okay, and then you're going to have a couple problems like this on your homework. This is really Algebra 1. It's just a reminder to get us ready for what we're going to do in this unit. If you have a fraction equal to a fraction, right, I can make this into a fraction, we can cross multiply. So I would have 5 times 1 equals 4 times 3x plus 5. So 5 is equal to 12x plus 20. I want it, now I've got a two-step equation. So I'm going to subtract 20. And I have negative 15 equals 12x. And we're going to divide by 12. So x equals, let's see. Good. Now, I want to talk for just a minute about what answers we can keep and what we can't keep. Okay, I'm going to go back to this first page real quick. I'll come back there in a minute. Come on. There we go. Here's the graph of my parent function. There's a whole lot of x's here that I can use. There's only one x that I can't use, 0. You can't make whatever makes your denominator 0. All right? That's called an excluded value. So I just need to make sure that my answer is not an excluded value. So I look at my denominator. So my excluded value would be, if I set my denominator equal to 0, so 3x equals negative 5, x equals negative 5/3. Is my answer the excluded value? No, so my answer is good. I get to keep it. If I look at number 6, what's my excluded value? What would make my denominator 0? Just -3. X equals -3. This is a constant. I don't have to worry about it. Nothing's going to turn that 7 into a 0. I only need to set this denominator here. If I set x plus 3 equal to 0, -3 would make this 0. So as I'm working my problem, if my answer has a -3, I would have to negate it. Okay, so I'm ready to cross multiply. I'm going to multiply the 3x minus 2 times the x plus 3, and I'm going to multiply the 7 times the 2. And it doesn't matter which side you write on the left and which side you write on the right. So the left-hand side is quadratic, right? I'm going to FOIL this. 3x squared minus 2x plus 9x minus 6, and this will equal 14. I need to set this equal to 0, so I'm going to subtract 14 from both sides. So I have 3x squared plus 7x minus 20 equals 0. And now I'm ready to factor this. How are our factoring skills? What did you think after last night? They're all right? Rusty? So I would multiply 3 times -20 and factors of -20 that add to 7. 12 and 5. And this one has to be negative then. So I would rewrite 3x squared plus 12x minus 5x minus 20. I'm going to do parentheses around the first 2 terms. What's my GCF here? 3x. If I pull out a 3x, I'm left with x plus 4. Right, which means I want an x plus 4 here, which I'll get if I pull out a -5. So my factors are 3x minus 5 times x plus 4. So if you have your factors, we're going to set each factor equal to 0 to find the roots. So this root gives me a -4. This one gives me 5/3. Are either of these excluded values? No. The only thing, if I had an answer that was that -3, I'd have to cross it out.